In this lesson, we're going to wrap up section 3.4. So there's one more section under the relative standing in addition to z-scores and raw scores that I'm going to quickly cover. And then we'll begin section 3.5, and that's the last section that we're going to cover in chapter 3. So percentile and percentile rank. These are also measures of relative standing when we speak of data values in terms of percentile rank. And you guys have definitely heard of scores or data values being ranked or spoken of in terms of percentile rank. So I'll give you an example. I'm just going to hop over to the whiteboard. So let's say, for example, we have a distribution of weight and it's bell-shaped. And let's say your weight is at the 80th percentile. So, a lot of times when little kids go to the pediatrician, the doctor takes their height, their weight, and then they put it on a chart and they say, okay, your weight is at this percentile and your height is at this percentile. Very common. But what does that mean, right? So how do we interpret that? So let's say, for example, your weight is at the 80th percentile. What that means is that you weigh more than 80% of your peers. So think of this as cutting off the first 80% of the distribution. So let me just use a lighter color here. So let's shade in the area or all the weights to the left of this weight, of your weight, and that represents 80% of the weights. So the way we interpret this is that you weigh more than 80% of your peers. The other way you could look at it is you weigh less than 20% of your peers, right? Because if I were to shade the entire distribution of weights, that would be 100%, right? If I shade in the whole figure. Now, I already shaded in 80%. So the area to the right of your weight would be the other 20%, right? Because 80% plus 20% adds up to 100%. So you could look at it that way too. So you could look at this two ways. Either you weigh more than 80% of your peers, or you could say that you weigh less than 20% of your peers. Let's look at one more example. Test scores is another common one, right? Like when you guys take the SATs or any sort of standardized test, not only do you get your raw score, but you usually get your ranking too, your percentile rank. So let's say, for example, that your score was at the 30th percentile, like I have here on this bell-shaped distribution for test scores. So your score was at the 30th percentile rank. What does that mean? So what that means is the area to the left is 30% of the scores. So in other words, you scored higher than 30% of the other test takers. So you scored higher than 30% of the other test takers. And you could also look at it from the other perspective, because remember, if I were to shade the entire area under the curve, it would add up to 100%. So if the shaded area to the left of your score is 30%, then the area to the right would be 100% minus 30%, which is 70%. So another way to look at this is that 70% of the other test takers did better than you. So that's how we interpret percentile rank. Whatever the cut mark is, so for example, the 30th percentile, the area to the left is 30%. If we're talking 80th percentile, the area to the left is 80%. So let's put this in perspective. If I were to take a symmetric distribution and cut it right down the middle, that would be the 50th percentile mark, right? And then let's say we wanted the 40th percentile. The 40th percentile would be to the left of that, then 30, then 20, then 10, right? So this would be the 10th percentile, 20th, 30th, 40th, 50th. Then we have the 60th, 70th, 80th, 90th, right? So that's how we could think of our percentiles. The 50th percentile would be the middle, the median. So let's go back to the notes with the definitions. So there is a difference in the use of the words percentile and percentile rank. In general, the percentile refers to the actual data value, while the percentile rank is the percentage value that ranges from 0 to 100, like I was explaining before. We could also divide our percentiles into tenths or deciles. Think 10. So the 10th percentile would be the first decile. The 20th percentile we can also call the second decile, and so on and so forth. There's really not too many examples that I'm going to do that involve deciles, but I just think it's important that you know that dec means 10, and we could divide percentiles into tenths. We are going to spend time, though, on quartiles. So quartiles are important. But you guys are familiar with quarters, right? Like how many quarters make up a dollar? There's 4, right? So if I want to take one whole and divide it into fourths, we call them quarters, and 4 quarters make a whole. So we could think of our quarters or quartiles as the 25th percentile, which we call the first quartile. The 50th percentile is called the second quartile, or Q2. We call the first quartile Q1. And then the 75th percentile, we call the third quartile, and we call that Q3. So we can break our data set into quarters, or 4 equal parts. And that we would call the 25th, 50th, and 75th percentiles. And we're going to do an example where we have to calculate quartiles in a minute. But let's put this all together now. So in section 3.5, what we're going to do is we're going to create a 5-number summary, which uses the quartiles along with the smallest data value and the largest data value in the set. And then we're going to put it into a nice picture called a box plot. And we'll use that to summarize our data. So before we talk about box and whisker plots, let's talk about 5-number summary, and we'll do an example. So a nice way to summarize or to describe a data set is by finding the 5-number summary, and that consists of 5 numbers. The smallest data value, the first quartile Q1, the second quartile Q2, which is the same thing as the median because that's the 50th percentile, the third quartile, which is Q3, and then the largest data value in the set. Let's do an example. So let's look at example 19. The following distribution is of annual salaries in thousands of dollars. So for example, this salary is not $55, it's $55,000. The next one is $57,000, we have $60,000, and so on and so forth. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19 salaries in my data set. So my sample size is 19. So what I want to do first is let's determine the 5-number summary for this particular distribution. So remember, the 5-number summary includes 5 things. It includes the minimum value in the set, Q1, which is the first quartile, Q2, which is the second quartile or the median, because that represents the middle, the 50th percentile, Q3, which is the 75th percentile, and then the maximum data value in the set. So those are the 5 numbers that make up our 5-number summary. Now, I already put this data set in order for you, but if you're going to find the 5-number summary by hand, you have to order the data first. But this data already happens to be in order. And now it's going to make it a lot easier to find these 5 values. So I think locating the min and the max are the easiest, right? So the minimum data value in the set is 55. And again, we're in thousands, it's 55,000. The maximum data value in the set is 90,000 or 90. So now what we want to find are the 3 quartiles, Q1, Q2, Q3. I think when you do this by hand, the easiest one to find first is the median, which is Q2 or the 50th percentile, right? Because that's right in the middle. And I taught you guys how to do that at the beginning of chapter 3. So we have 19 data values, which is odd. So we are going to have a number right in the middle. So let's just count in to the middle of this data set. And we want to find which number is right in the middle, and it's going to be 67, right? Because to the left of 67 is going to be 1, 2, 3, 4, 5, 6, 7, 8, 9 data values, and to the right of 67 we're going to have 1, 2, 3, 4, 5, 6, 7, 8, 9. So 67 is the median, which is also the same thing as the second quartile. So Q2 is equal to 67,000. Now we need to find 2 more things. We need to find Q1 and Q3. Q1 is the 25th percentile. So remember up here, Q1 is the 25th percentile. So if we looked at the first quarter in terms of our data set. Now, I think an easy way to look at this as, look, 67 is right in the middle. This divides our data set in half, right? It's the median. So let's look at the lower half of our data, right? This is the first half of our data. If we were to chop that in half, now I'm going to have my first quarter, right? So in order to get Q1, take the median of the lower half of your data set, the data that's to the left of the median. So if I look at my lower half, right? So this is the lower half, find the middle. That's going to be Q1. And that's going to be 63. So Q1 is going to be 63,000. That's your 25th percentile. And we're going to do something very similar. Now let's look at the upper half of our data set, right? Everything to the right of the median or the 50th percentile. What's the middle of the upper half? That's going to be your third quarter, right? So it's going to be Q3. So let's find the data value that's right in the middle of this upper half of our data set. And that's going to be 78. So Q3 is going to be equal to 78. Now notice that when I look at the lower half and the upper half, I'm not including the median. I'm looking to the right of the median and to the left of the median. So this would be my 5-number summary. And this is a nice quick way to describe the main characteristics of a data set in terms of quartiles. In addition to this 5-number summary, it's nice to make a picture out of it, which is called a box and whisker plot. But before we do that, I want to show you how to make your life easier and find the 5-number summary in the calculator. So going forward, you don't have to do it by hand. Honestly, it's tedious if you have to order them first and then find Q1, Q2, Q3. Going forward, I want you to use the calculator to get your 5-number summary. And the way we do that is using a 1-variable stat, just like we've been doing to get the mean, the standard deviation, the median. So I'm going to write this down. So to find the 5-number summary in the calculator, do a 1-variable stat, just like we've done before. So I'm going to have you pause here, and I want you to enter this data set into the calculator. And let me get rid of some of this drawing so it's easier to see. So I want you to enter this data set into your calculator, and then we'll do a 1-variable stat together. So pause if you have to, enter this data set, then unpause. and go with me to my calculator. So I already have this data set in my calculator in L1. I entered this into L1. So now I'm going to do a one variable stat. So remember, we have to press stat. We go over to calc, we arrow right to calc, and it's option one variable stat. Now you have to tell the calculator what list, L1 in this case, for me, leave frequency list empty, and then go to calculate. And we're going to get this familiar output, right? With the mean, the standard deviations, so on and so forth. If you scroll all the way to the bottom, you're going to see your 5-number summary. You see the 5-number summary at the bottom. It starts with min x, which is 55, Q1, which is 63, the median, which is 67, Q3, which is 78, and the max, which is 90. And these are the exact values that we got when we did it by hand. But look at how much quicker it is to find the 5-number summary in the calculator. So I'm urging you going forward when you do homework questions or practice questions or test questions or a quiz, and you're asked to find the 5-number summary, use one variable stat in the calculator. So the last thing I want to do before we wrap up this lesson is let's put this 5-number summary in a picture. Now, this graph is called a box and whisker plot. So a box and whisker plot, a box and whisker plot is a visual display of the 5-number summary. And it helps us look at the characteristics of a data set. It helps us see what the shape is, if it's bell-shaped, if it's symmetric or skewed. And it's pretty simple to draw. So I have the steps right here for constructing a box and whisker plot, and we'll follow them together right here to construct the box and whisker plot for this 5-number summary in this problem. So the first thing that you're going to do is you're going to draw a horizontal line and scale it from the smallest to the largest data values. So the smallest data value is 55. So I'm going to start at 55. And we need to go up to the largest data value, which is 90. Think of a scale that works. I'm not going to count in ones, meaning 55, 56, 57, all the way up to 90. The graph's going to be a mess. But I think fives work, right? Let's go in fives up to 90. So we're going to go 55, 60, 65, 70, 75, 80, 85, 90. So that's a perfect scale. So now what we're going to do is draw, so I'm on step 2, draw a rectangular box above the horizontal line with the sides at the first quartile, Q1, and the third quartile, Q3. So Q1 is 63. So I'm going to say 63 is, between 60 and 65. So above this horizontal line, I'm going to draw a vertical line, which is going to be part of the box. So this line represents 63, which is Q1. Now we're going to draw another vertical line for Q3, the third quartile, which in this case is 78, which is a little bit less than 80. So I'm going to put that vertical line a little less than 80. So let's say this is about 78. And we connect them, making a rectangle. And step 3 is to draw a vertical line within the box to represent the position of the median. And the median in this case is 67. So 67 is between 65 and 70. So let's say approximately here is 67. So that's going to be the value of Q2. And then the last part is to draw the whisker. So put a dot for the smallest value and the largest data value, and then we're going to connect it with a line, and those are the whiskers. So the min is 55, so I'm going to put a dot right over 55, kind of center with the rectangle, and then I'm going to put a dot where the max is for 90, center with the rectangle, and we're going to connect them. And that's how we draw a box and whisker plot using a 5-number summary. So what we'll do in the next lesson is we'll continue talking about box and whisker plots. We'll talk about characteristics and how to interpret them, and we'll do another example.